Again, so good afternoon and welcome everyone to the Airbus Protect Artificial Intelligence Conference and Networking. So we are here today at the Paris show in Paris, France. My name is Mathieu Enchambaud, working at Airbus Protect. I am the communication task owner in the MLEAP project, and today I will be the moderator of this session. Thank you all attendees for joining either physically and virtually, and welcome back for those who were with us a month ago during the EASA AI Days that took place on May 16 and 17th, and as well as on the MLEAP Stakeholders Day. It's good to see you again, and thank you for sticking with us one more time for this project. So, as you know, today's project is the R&D project called MLEAP, dealing with artificial intelligence, which was founded by European Union Horizon and the EASA, on which Airbus Protect has been the leader for over a year now, alongside with two other partners that are here with us today, LNE and Numalis. So before we get started, I think it's really important to clearly explain the difference between today's conference and the one we had a month ago during the MLEAP Stakeholders Day number 2. So a month ago, we really went into the technical details of the three tasks and the progress being made on the project. Today, we will not do that. We will not go as deep as into the technical details. We will present you a lighter, I would say an easier version of what was presented a month ago. So that's really the big difference between those two conferences. And as you know, this event is recorded, and the replay will be available on our YouTube channel at Airbus Protect within the next coming updates. So last but not least, we'll use Slido for the Q&A session. So right after this conference, we will do that. So it's Slido is pretty easy to use. You just take out your phone, scan the QR code that's displayed on the screen, type in the password, and then you will be able to ask your question directly through the application. Since we have also people in the room, we might, if we have time, we might pass the microphone around, then people can directly ask the question out loud. Okay. So that we already went over the agenda. So without further ado, I think we can get started with the presentation. Last but not least, at the end of this conference, we will have a quick networking coffee for those of you who want to stay with us and keep the exchange going. So after the conference, we will do that. So we'll end the conference online, and then we will continue with the ones who are with us in the room today. Okay, so let's start the presentation with the introduction of the MLEAP partners, starting with EASA. So Guillaume, the floor is yours, and as well as you, Xavier.
Thank you, Mathieu, for welcoming us here. So I am Guillaume Soudin, EASA AI Program Manager, in charge of developing and implementing the EASA AI roadmap. And I will give the floor to you, Xavier, to present yourself.
Good afternoon, Xavier Henriquel, Safety Assessment Expert in EASA and EASA Project Tech Lead.
Just to mention, on the other side, we have also François Triboulet, who is the project manager for the learning assurance in the AI program, who is not with us today. And Willy Ziegel is the project manager for MLEAP. But you have, I would say, with Xavier and I, the sponsor and the technical lead for the MLEAP project within EASA.
Okay, for LNE, I'm Olivier Libert. I'm the tech leader for consortium side of this project, and we also have Sven Ribeiro, which is work package owner for work package 1, data, representativeness, and completeness.
So, hello everybody, I'm Sven Ribeiro. So I will be talking to you later, so you will see me again.
Hi, I'm Arnaud Yolalen. I'm the CEO of Numalis, and I'm the task owner of Task 3, and we'll also speak later more on that.
Hello, I am Michel Kaczmarek. I'm the project manager for MLEAP at Airbus Protect.
Hi everyone, my name is Izzy Bukasan. I'm data scientist from Airbus Protect and I'm a technical advisor on the MLEAP project. Yeah.
Hello, Jean-Baptiste Rouffet, as tour owner, and also part of Airbus Protect.
Hello everyone, Thierry Bertrand, responsible of digital activities and MLEAP teams is and the digital department of Airbus Protect.
Okay, so let's carry on with the presentation of the MLEAP project. So floor is yours again, EASA.
Thank you, Mathieu. Yes, so thanks all for being here, here in the room or on the WebEx. In fact, before giving the floor to the consortium and the technical slides on the other side to reset the context and the scene on where this MLEAP project lies into the roadmap effort on the other side. We have presented already the people, so I am AI program manager and MLEAP project sponsor. Xavier, who will take the floor also just after, is a safety expert at EASA, tech lead for the MLEAP project. And we have a great support from François Triboulet, who is ATM ANS expert and also a project manager for the learning assurance in EASA. So the big picture is actually this EASA AI roadmap, which we published in 2020. And that was the starting point, I would say, of a journey. Since then, we have deployed a number of efforts to get within this phase one that you can see at the bottom here of the time frame, exploratory and first guidance development, to deliver, I would say, in terms of with a vector that we call the concept paper, to deliver a set of anticipated objectives at the top level and possibly anticipating also means of compliance for the deployment of safety-related applications in aviation. The first thing we found out when doing the impact analysis on aviation was that it impacts nearly all domains. It's not only a product certification, it's really about ATM, about maintenance, about aerodromes, safety management. There is a lot of applications coming our way, all of them sharing a statement of concern, an issue, let's say a common issue, which is the level of trust that we can put in an application when we deploy it for a certain level of operation. This is where we have tailored this notion of AI trustworthiness as a key concept for the roadmap implementation. And this AI trustworthiness concept takes a shape that you will see on the next slide. Before leaving that one, I just wanted to make clear one thing. We have sliced down, let's say, the effort in three levels, three subsequent levels of deployment of AI. Level one is about assistance. Level two is about human-machine teaming. Level three is something we have not entered yet, whereas we've released already a concept paper or a proposed concept paper for the level two in 2021 for level one, 2023 for level two. We are now entering in a phase where we will look at what we call advanced automation. And this is something that will bring us actually in different even area of usage of AI, I would say, towards autonomy, which looks like a quite let's say, a remote target for now, but a lot can happen in between. We have a phase two that is foreseen from the start to start in 2024. We are currently working on a rulemaking plan, and the concept for rulemaking is also developed in this second issue of the Roadmap 2.0, which you can see here, which was released last month. And that's the occasion at which we had the EASA AI Days that Mathieu was mentioning, where we unveiled this Roadmap 2.0, and we had also the chance of a second day, Stakeholders Day on MLEAP, to go deep inside the technical aspects of the report that has been published by the consortium. What is trustworthiness for us? It boils down to four building blocks, which we kept, I would say, from the first issue of the roadmap. So the trustworthiness analysis building block has not changed. It's about characterizing the AI application, performing everything that is safety assessment, information security assessment. Also, this is the place where we lay down the essence, I would say, of what is called ethics-based assessment. That's something we can talk about a bit more in details if you have specific questions about it. For now and for today, the main focus, and actually where MLEAP lies in terms of activity, is in the AI assurance building block. Some may have seen that there was an extension in the terminology from learning assurance to AI assurance. This is along the line of the extension in technical scope that we have tailored in Roadmap 2.0. We started with learning applications. That's exactly what was coming our way in the early days, I would say in 2018, 2019, when we started thinking about what to do with AI. Now we see more coming on the symbolic AI side, on hybridation of data-driven with symbolic AI approaches. And this is something we have expanded in the Roadmap 2.0, and which we will progressively expand in the scope of the concept paper guidance into this AI assurance block. That creates a block that is really focused on the system, on the AI-based system, so getting a level of confidence of the intended function of that system. Then we have a block that used to be called explainability that has also been inflated in scope when we were entering this development of what we call level 2, human AI teaming, which we can also go in more detail. That's not the scope for today. Let's say has at least 2 levels, the level of human AI cooperation, human AI collaboration. That's 2 levels at least that we see. There could be actually many more. And this is the block under which we have created a first set of objectives to be met in order to be at the right level of safety when deploying this quite advanced, I would say, level of assistance or automation in a cockpit or in an ATCO control room. So in any type of application. The last block is the safety risk mitigation. It's the, I would say, the innovation management block, where we don't know what we don't know. We may have very tough objectives to meet in the AI assurance in the human factors for AI, sometimes without practicable means of compliance today. That's actually the purpose of the MLEAP project, as you will see in a minute. And the safety risk mitigation is really our strategy to deploy and certify or approve with certain risk assessment, risk mitigation, and capturing, I would say, the essential assumptions that we need then to verify possibly in the operational phase. All what we publish is on the website that you can see here on the left-hand side of the screen, EASA Europa EU/AI. You land on the AI page of EASA, and we can hear the Rafale in the background. Great on the WebEx. This is the page where we publish everything, the roadmap, of course, the concept papers for consultation, and the innovation partnership contracts reports, the link also to the MLEAP public report. That's a pretty informative page. Now, looking at the top challenges that we have on the way, there are many more challenges than that, but it boils down, I would say, to 3 main topics. One is we've developed a learning assurance concept already in the level 1 guidance. Xavier will present that in a minute. We have really identified specific objectives that are considered necessary at this stage, but for which the means of compliance are actually very challenging, sometimes unreachable, sometimes difficult, depending on the complexity of the model, depending on the dimensionality of the input space. So we have to find out and dig into more possibilities to find out practicable means of compliance. That's the heart of the reason and the main reason for starting this MLEAP project. And you will hear a lot more about it in the coming hour. We have also the operational explainability and human-centric aspects of AI, which are a challenging topic by itself in the sense that human factors, of course, is a topic we are managing in certification for a long time. But with the human AI teaming concept, we go really one step beyond. With the AI technology, we also go one step beyond sometimes in the need for explainability. So there is a need definitely here also to focus and with the research, but also with the working group that is led by EuroCAE and SAE, the joint working group we are participating in. We need to find out the right level of objective and means of compliance. Ethics-based assessment is a huge topic, of course. When AI is deployed, definitely there are specific ethics concerns that comes with it. We've tried actually to start from the guidelines that were published by the European Commission high-level group in 2018, which was the best reference point at that time. Definitely the EU AI Act might change a bit the scope here, but starting from there, we had actually a first go and a first exercise on mapping, I would say, the different topics, ethics-based topics. I would say ethics-based, it's not all about ethics, a bit wider scope, to the technical building blocks from the AI roadmap, from the trustworthiness concept. We managed it to a certain extent, to maybe 80-85%. We still have a number of topics, in particular linked to societal aspect in the Gear 5, Gear 6, that require further assessment. Partnering on research projects is a key driver for the guidance. That's a big message. Really partnering in a larger scope with all stakeholders of the aviation community is very important for us. We cannot describe or we cannot develop a guidance in isolation. We are doing it interacting with use cases, using them as test benches to feedback to the guidance, whatever is unclear, missing, etc. We've done that for 3 years now. We have innovation partnership contracts. We had some with Daedalus. We had one recently with Collins Aerospace. And we have also memorandum of understanding with a number of companies, which help actually maturing this guidance from this perspective. At the bottom, but very, very important also to mention, is the standardization effort that has started, as I was mentioning, in the EuroCAE WG114 joint SAE G34 committee. That's a very big source also of discussions and feedback to the guidance, to the concept paper, even before we enter in a rulemaking activity for the consolidation phase I was mentioning. And last but not least, research is a key as well. We inject to research our problematics. You will see what MLEAP is bringing back to us today. But we have also CESAR 3 Clean Aviation 2 frameworks that bring a lot of AI applications, sometimes actually bringing us a bit closer to this level 2A, 2B that we are theorizing in the new concept paper. So there is a lot ongoing, and that's a very, very important ecosystem and dynamicity in the exchanges for the purpose of everyone here. And I pass the floor to Xavier to now dig into this AI assurance, learning assurance building block.
Thank you, Guillaume. Before I go into how MLEAP is dealing with the key challenges that Guillaume highlighted, let me first remind quickly the W-shaped learning assurance concept. So one key building block in the AI trustworthiness concept is this AI learning assurance block. It's instantiated in the guidance along a W-shaped process that is directly derived from traditional development assurance techniques that we use for safety critical application, and that visit all stages of a learning process, starting below the dotted line with the key steps of the key objectives related to data management, before moving to the learning process and its verification, before going to model implementation and its verification. So this framework that is structuring EASA concept paper is pretty stable at this stage, but we identified early the need to define means of compliance for each of these blocks and finding practical means of compliance, which was not necessarily a given. And this is why we have launched several initiatives. You mentioned Formula IPC that was focusing on some of these blocks, and MLEAP that is divided in several tasks is specifically designed to find some practical means of compliance for the EASA guidance. It is a 2-year project funded by Horizon Europe with around 1.5 million euro budget over 2 years, and it is executed by a research consortium made of Numalis, LNE, and Airbus Protect. So this project is, as I was mentioning a couple of slides earlier, is structured along 3 technical tasks to pave the way for future applications. The first task has to do with data, because of inherent cost of data and because data is essential to achieve proper performances. One of the reasons why also we wanted to have a technical axis along the data is because we identified early that there were limited tools and methods that were readily available to deal with data completeness and representativeness. The second task has to do with what is called in literature generalization guarantee. Not only we want the model to perform well on training data, but we also want it to perform well within the operational design domain. And we've designed the project so that we can assess various methods or tools that can help us boosting generalization and hopefully find some ways to quantify the generalization guarantee. The third task has to do with algorithm and model robustness. What we wanted to do there is first to define well this concept of robustness. At this stage, in the AI domain, standardization is ongoing. So what we wanted to do first with this task is to validate the concept of robustness that we have in the EASA concept paper before exploring different methods and tools, ranging from experimental methods, statistical methods, and formal methods. This task 3 is a continuation of what we started with Formula IPC with Collins Aerospace. Actually, Formula IPC was finalized last month or 2 months ago, and the results from this public IPC with Collins are going to be an input to this task 3. Throughout the project, the various tasks are feeding the EASA concept paper. We don't wait for the end of the project to update EASA guidance. We are having various events to disseminate the results and progress of MLEAP. And if I go to the main milestone and planning for the project, as you can see, MLEAP is running in parallel with the EASA AI program during the AI concept paper phase. So MLEAP is feeding the AI concept papers. It is divided in 4 phases. At the end of each phase, we have a stakeholder day. As mentioned by Mathieu, the stakeholder day 2 was held last month in Cologne during the EASA AI Days 2023. It followed the publication of the first public report by the consortium. We are now at the beginning of phase 3, where we will work on practical practical use cases. This first phase 3 is an interim step before phase 4, that will be the end of MLEAP in May 2024 next year. And at this stage, we will have a final public report with the result of the project. And I will leave the floor to Hilary.
As for the evaluation and the experimentation part of this project, so we have selected 3 main use cases from the aeronautics domain, where the objective, in fact, is to lead and support the method selection and also the process of verification of our recommendations about methods to be used for every task, and then perform a comparative evaluation and finally validate our findings. As for the first use case, it is a speech-to-text application for the air traffic control, where the objective is to correctly translate the spoken instructions in the ethical exchanges into text for safer monitoring. So on this kind of application, we identify 3 main challenges, including the language understanding, spoken instruction understanding, and also the voice print recognition. And on the MLEAP project, we are more interested on the X, including the language understanding and also the instructions interpretation, where for the speech data analysis, we can identify 2 main axes to explore. We have the production mechanism, where we need to handle the background noise and also the intelligibility of the context, also the speech rate, and handle the other language-related challenges, such as the accent and the multilingual aspect. And for the evaluation part, so we have been provided with model and data from internal Airbus projects, including also open source data sets and models for the evaluation part. So here we try to provide a synthetic representation of the model and also the data. And if you want to know more about the data and the models, please check the complete report of the project. Second use case is a visual inspection. It is in fact aimed to help the operators to promote the maintenance operations and also their planification, where the objectives, the main objective is to support, in fact, the detection of two kinds of damages, the DANE damages and the lightning strike impacts. So as for the previous use case, here also we are provided with different trained models and data sets from internal projects. And one of the most important challenges for the MLEAP project is not only to classify correctly the damages, but also this is an ongoing project and it will enable us to directly evaluate our findings and the methods and the recommendations that we will make after on this project. As for the third use case, it is the well-known AK6, which is a more open source use case, where the objective is to help, in fact, the model to find the next direction and the next move in order to avoid the collisions. We have a set of features represented in the lookup tables, and one of the most important objectives is to compress these lookup tables into neural networks and then evaluate the ability of these neural networks to reproduce correctly the learned table. Yes, and so I will let the next phase.
Okay, so we had the pleasure to release like a month ago a very nice doorstopper called the MLEAP delivery variable, the first version. That's going to be the final version in a year. And it's a nice 260 pages document that you can read with pleasure before you go to sleep. And the report is about 3 topics, which are mostly but not strictly identical to the task. One is data. The question of representativeness and completeness is the main one, but there's also the question of corner cases and outliers, which is looked about in it. There's a question of models, training models, and everything that comes with generalization properties, and how you right-size the model, if you be sure whether it converges or not, if it's if it's to converge in fact, and things like that. And there's a problem of evaluation, in particular the question of robustness and stability, in addition to the simple question of performance. And the tasks are handled in similar ways. Just we have a different level of advancement depending on which task we are on. And there are 4 points we want to do on every topic, every question. What's the definitions? What are the meaning of the test? The terms, like what stability means exactly, what ODD means, things like that. What do the various documents, the standards, the concept papers, different normalization that are going on, all the public white papers you can define, and at the end, what meaning we choose for the report, because that's a really important question. We have to know what we're talking about. From that, we go to a state of the art when we do a review of scientific literature and of existing methods and tools. And the aim is to construct a selection grid where we can associate use cases and the methods and tools. So it gives you an idea of, in that particular case, what methods can I use to have a chance to prove conformity or at least properties of my system. Then we go into experimentation, because these are all scientific literature, so it's a little theoretical, and we want to try the tools and the method, the real data and models, to see how it goes in the real world, especially when it comes to scaling, because there's a lot of methods that don't actually scale, but we won't know until we try. And of course, ending by trying with the aviation use cases Thierry just presented. And then on top of that, we want to project that in the W-shaped process that is pushed by EASA. So to generate the methodology as much as is reasonably possible, and structure the input so that it can be used by the EASA in their work, so that they have their means of compliance, or possible means of compliance everybody can use to actually do interesting things with their systems. And I give the floor to Sven.
So hello again, everybody. So we'll be talking to you about task 1. So task 1 focused on data completeness and representativeness. So maybe we will start with definition of these concepts. So in the document, we consider that a dataset is complete if it sufficiently covers the entire space of the ODD of the intended application. and it is representative when the distribution of its key characteristics is similar to the actual input space of the intended application. So in task 1, we achieved the 3 objectives so far. The first one is to draw a state-of-the-art of the tools and methods available to assess the completeness and representativeness of datasets. We structured this approach through a list of influence factors. Then we performed a synthesis of the state-of-the-art through what we call a selection grid of methods. And finally, we started the preliminary testing of these methods on actual datasets in the general case of machine learning and not specifically for the moment on the MLEAP use cases. So about the state-of-the-art, we identified, as I said, a number of influence factors that we grouped into 3 categories. The first one is called technical requirements. It's basically all the requirements that influence the creation of the specs and the ODD during the development phase. So it includes things like the intended behavior of the application, the model architecture that has been selected, the dimensionality of the data, and others. The second category focuses on processes. So it includes things like data management, data quality, also data synthesis, which we distinguish from data augmentation, also sampling, labeling, and pre-processing. And finally, there is all the other data quality requirements that interact with completeness and representativeness. So things like balance, relevance, diversity, or currentness. So the main takeaways of our state-of-the-art, first, there is a general lack of maturity in the field of AI regarding data quality. That means that there is a lot of good work on data quality, but it's not structured and you don't have method that will tackle explicitly influence factors and their relationship to properties like completeness and representativeness. There is not this structured approach. The second takeaway is that an exhaustive data quality is challenging to attain because you have data quality requirements that might be mutually exclusive. For example, if you want to enforce a perfect balance on your dataset, you will be completely giving out the representativeness of your dataset. There are also what I would call secondary takeaways, like in literature, there is still a culture of if we didn't clean our data enough, it's still okay because the model will figure out the delta, which is not a very good strategy. Of course, there is no magical method that will allow you to assess the relationship between any factor of influence and the completeness or representativeness of your dataset. And there is still a challenge with high dimensional data because all methods are not readily operationable on high dimensionality data. So moving on to the second objective that we achieved, the synthesis. So basically, we took the more than 60 assessments methods that were discussed in the state-of-the-art, and we boiled it down to 20 methods that were selected for further testing. We applied 2 criteria for this selection. The first one is the maturity of the method. So basically, the question of is there an available implementation, or is the method implementable in a reasonable time, considering the time frame of the MLEAP project? And also, the second criterion is that the method is in line with the project objectives. So basically, can you assess completeness or representativeness quite clearly with this method? So moving on to the testing phase, we worked on 4 main approaches. The first one is PCA. So PCA is principal component analysis. It's a very classical dimension reduction technique that worked that gave interesting results for the moment. We also worked on a classical measure that is called entropy. We computed entropy on images. It was quite interesting too. We also worked on a graph method that worked on the feature combination distribution and that appeared as a good complement to PCA. And finally, we worked on sample similarity through specific metrics because sample similarity is a very vast subject, and this approach is also very promising. the main takeaways of all this work is that no method is self-sufficient. Basically, you will need to combine method, tools, and metrics to get the most insight on your data. No method is universal. Like all the combination of methods that you might use will have to be tailored to your specific task or data set. Of course, completeness and representativeness will only be accessible with respect to the ODD specification, which means that you will never have a method that will allow you to say my dataset is complete with respect to everything that can happen in real life. And the last takeaway is that there is a trade-off between completeness and representativeness. So if you consider corner cases, for example, corner cases are rare in occurrence but serious in impact. So you want to cover them well in your model. But the idea is that to do that, you don't have much data. You might be tempted to add a little more data. And in this case, you would be training off a little of your representativeness for the sake of completeness. So I'll leave the floor to Airbus Protect for task 2.
Okay. So the task 2 is focusing on generalization property. This presentation will be articulated about with three main pillars, which are the first one is thanks to the state of the art. We present the available methods and tools that we have identified, such as the generalization bounds. And we'll present also the barrier and generalization guarantee for machine learning and deep learning, and the limitation we have identified concerning the available method, and the common practices. Then we jump to a second part where we have the selected method identified and their projection in the W shape for the machine learning development pipeline. I will start with a quick reminder about what we are speaking about when we say supervised machine learning. So the first idea is, based on the data I have, I will parameterize an algorithm to secure that based on an input, for example, a picture, I can predict what is the right answer. For example, I present a picture and I want the algorithm to tell me this is a cat. To do so, we are using examples where we say to the algorithm, this is a cat, this is a dog. And thanks to the optimization of the algorithm, we are minimizing the error that the algorithm is doing on the samples. And what we want at the end is that the algorithm is capable to generalize, meaning that we are expecting few errors on unseen data. This statement is based on the assumption that we have regularities behind the data, and those regularities are discovered during the training phase. So here clearly we see that there is a key concerning the generalization, which is the data quality, thanks to the task 1 that Sven just presented previously. Parameterized machine learning, let's say we are attacking three main aspects. The first one is the approximation. We have to do some hypotheses concerning what is the architecture I will use for my neural networks, and this is driving a certain bias because we need to secure that the function which will be part of the class that I've selected is the right one. Second point is we are optimizing the algorithm to find the right parameter. So here also we need to take care about how I'm optimizing and secure that the minima that I'm obtaining is really a good minima close to the global minimum. And the third one is the estimation, because we don't have access to all the data, especially when we are working in high dimensionality for the data, high complexity for the neural network. It's important to say that we are making some assumptions and we are using a statistical approach. The generalizability is a capacity of a model generalize what it has learned during the training phase and to be able to adapt to new contexts and new environment. We want to estimate that to secure a certain assurance level of our algorithm. And for that, we have what we call the statistical bounds, where we say that globally, the error that my algorithm is doing on the full ODD, the full domain where my machine learning should operate, is less than a certain value. And to measure that, I can use the data I have to make some extrapolation on the error on the full domain. Different bounds are existing, some based on different properties of my model. So I can mention the uniform convergence, the uniform stability base, and the algorithm robustness based one. For the last one, let's say we have some geometrical interpretation of those bounds that can help us to interpret and to go when we are not in a standard case where the data are not identical versus our target world. So we have identified 17 bounds that we will test during the phase, the experimentation phase. Second point is we have also indicator, okay, where we say that it is necessary condition to have a good generalizability, but not sufficient. And for that, we have some indicators which are based on the evolution to secure no overfitting or underfitting, for example, and also the test-based one where we are analyzing the correctness of the result during adversarial attack and so on. And this part is supported also by the task tree that will be presented just after. I will hand over the floor to Thierry, who will continue the task 2 presentation.
Thank you. Now, after analyzing all these different methods, we have selected a set of methods for the bounds estimation. Here we want to make a global overview about the tasks and also the different steps that we need to perform during the journey going from the task and the data and the industrial objective to the model and the good model estimation or construction at the end. Sorry. So we start by the modeling, the training, the evaluation. However, we have identified after the analysis of the state of the art a set of limitations and pitfalls, if I can say, that harm in fact the model and prevent them from being generalized. The first one is the misunderstanding of the generalization bounds. Sometimes, so as Jean-Baptiste explained, we cannot apply all the bounds or all the existing methods for the same use case, or we have some methods that can perform well on one use case, but poorly on another use case. So to remedy for this, we can deal with the models overfitting and underfitting in the industry, such as using the regularization the techniques for the training adaptation and also the warm-up and the fine-tuning, etc. And we can also adapt other methodologies such as the model and network architecture adaptation. The second problem is the common mistakes in practice, that nowadays a lot, or just not to say all, the data scientists use to reproduce during this journey, and it can include the inappropriate training objective adaptation pipeline, or an inappropriate complexity of the model or architecture to translate well the task objective and the mappings between the input and the output domain, etc. So in order to remedy for this problem, we can bridge the gap between the experimentation and the industrial expectations. So we need nowadays to redefine, in fact, first the objectives from the point of view of evaluation and experimentation in order to meet better the industrial objectives and the targeted performances. So there is no one method and no one metric that can show that the model is good enough for being implemented in the target system. So there is a lot of indicators that can help us to say that the model is good enough to go into the industry. So we had too many times several discussions about using the term guarantee on the generalization So this guarantee is not only one metric, it is not only one method giving a good result, but it is a combination of a set of methods for the evaluation and the performances verification. The other element is the gap between these two domains and how we view the good model from the experimental and the evaluation point of view, and how this 95% or 85% accuracy is good, and do I have in fact all the industrial KPIs or the main objectives from the industrial point of view well represented into the experimental setup. And then finally, we have a set of unhandled machine learning and deep learning testing limitations and challenges. And nowadays, we are not saying that the testing-based approaches to validate machine learning modules are bad. However, they come with things that we can leverage. For example, well-defining the scenarios from the point of view engineering and the classical software development. We have a set of testing and data samples to evaluate if the system is having a good behavior and the expected one. So we can use this mechanism in order to validate also the module that includes the machine learning model that is trained. So after the evaluation, we can leverage also these testing approaches in order to have more guarantees between brackets, which means that another indicator that my model fits good the target system. So in order to put all these elements together, so we provided a first architecture of a global pipeline that revisits the existing approaches for building machine learning and deep learning models. It has been further adapted and developed well on the second phase. And here is the global architecture of this pipeline. So the objective here is to put together all the methods and the analysis that we performed during this journey, analyzing the state of the art and identifying also the suitable methods depending on the target use case, depending on the target system, etc., in order to in the first step, make a good evaluation, a qualitative and a quantitative evaluation of the dataset. In the posterior evaluation, here it includes also the generalization bounds assessment and the metrics identification to meet better these industrial objectives. And then after the model development, so we have this model and the benchmarking that represents better the objectives and also the target task. We go into the training, then perform a posterior evaluation that uses the set of metrics that we have selected, but also make a parallel evaluation with the industrial KPIs. If I have a good enough model from the point of view of industry, so I have validated the guarantees that I gave before training the model, I can go into the implementation phase. However, if it's not the case, I will have a step back into the model development in order to take into account the influencing elements that prevented the model from reaching these industrial objectives. And after this, so as another step, as it is presented previously by the EASA, we aim on the MLEAP project to feed the whole pipeline of the W process, the W-shaped process, with the different findings from the MLEAP project. Here we try to make more focus on the generalization and the learning evaluation. So in the first panel, we have from the learning process management a set of approximation, optimization, and estimation practices, such as the training algorithm selection, setting well the architecture of the model, select the loss function, review all these metrics, because it's not only sufficient to provide a model, provide an architecture, then go faster in the implementation, but we need to prepare these first steps more carefully in order to make sure that we will have less steps back after the model training. The second part of the optimization and estimation that comes into the down part of this process, including the model training step and also the training and the learning verification with the different selected metrics, and then further go into the approximation, optimization, and the estimation, where all the in fact the generalization and training elements. So we have a set of analysis to provide to the industrial responsible, for example, presenting the ability of the model to fit into the target system and how it behaves after its implementation. Because after this step of implementation, nothing will guarantee that I cannot go back into the other step because my model have lost a lot of performances. So in order to alleviate as much as possible this going back into the process, that's why we have suggested into this part of the pipeline to take into account the set of inference environment elements. So we call it like this in this part, that it can include elements from the target system and also environmental elements such as the blurring images, etc. We had also a first step into the implementation and evaluation. We used so far the speech-to-text use case for air traffic control. So the latest achievement of this evaluation aim to first compare the existing models that have been trained on the Airbus datasets that represent a set of recorded speech on real life on the French airports to the behavior of deep learning models using two different pipelines with zero shot, which means that the deep learning model has not been trained onto the Airbus datasets, and it is just evaluated into the open source data, and compare these models to the fine-tuned ones, where here the objective is first see in fact the advantages of adapting the model to the context and taking into account the noise behind the scene, so the noise included in the data. So this is an ongoing work, so it is not yet published on the public report, but more results are coming soon. I think I will finish here and let the floor for task 3. Thank you.
All right, so task 3 is about robustness and stability. So the main objective is first to make a large review of the methods and tools and basically of the state of the art regarding the concept of robustness and stability, which has been done and published under the first deliverable of the MLEAP project. We also focus on analyzing the notion of corner cases, abnormal inputs, which relates to task 1 on the representativeness of the data and the difficulties of such edge cases can cause to the system. In the next step, we will focus now on how these instability can impact the design or the operational phase of the AI system, and then make the demonstration using the use cases that was presented just before at the beginning. But first of all, let's talk a little bit about the concepts. So we make a large review of all documents that are talking about robustness or stability, and we found out that there are some similarities between definitions in certain documents, but it's not always the case. Some concepts are different, for example, between the ISO standardization document on AI and the EASA concept papers, but there is ground to make an alignment of the concepts. Basically, stability, even if it is absent in the ISO definitions regarding AI, is basically the notion of robustness in ISO. And robustness, in the hand of the EASA, is a little bit larger than what the ISO is thinking, but it's not very far away. And so we can make alignment between the two and have common ground in order to have common requirements between a more generic horizontal approach in the ISO and a more vertical and tailored for the aeronautic from the EASA. So even though there is different requirements, we can make them work together. In the ISO, we identified three main methods to address the topic of robustness and stability, which were introduced just before. So we're talking about statistical, formal, and empirical methods. I'm going to detail a little bit that after. Also, doing that, we managed to make a study regarding the maturity of the tools and the implementation in the industry of this concept. And we can analyze the scalability of such methods towards real case industry grade, for example, neural networks that can be used, and not just scientific papers analyzing toy examples using their tools. So we want to measure how much effort would be needed in order to go toward a real case industrialization of such methods. So using the basis of the EASA concept papers and the ISO, we define, we extracted, some of the properties here. So for example, stability, obviously, but also bias and variance relating to underfitting and overfitting, measuring the quality of the training of the model. Also the concept of relevance, which is tied to the notion of explainability that can be used also to assess robustness. And the concept of reachability, which means that how much my system can go in a wrong direction over time, and can I bound how much it can go right. So, like I said, we identified three main methodology to address this concept. So, first of all, statistical. I guess this is the most applied today in the industry because it's really well known by most of the data scientists. They are, let's say, even trying to do this kind of technologies. It's rather easy to set up. It's easy to cover grounds even far away in the domain of use, but you're only relying on data sets. So it's only isolated data points you have, and you have to have a proper way to express the data set you want to use, otherwise you might introduce some bias. It relies mainly on combining different metrics that are more or less suitable for the need you have, and also can use corpus simplification, for example. Formal methods, on the other hand, can address high dimension space and have local guarantees. So you're not relying on sampling. You can have a property validate on a subspace. However, it's a local subspace. You won't be able to validate between minus infinity and plus infinity at once. That's a little bit too hard. But you can validate locally among a lot of examples. And you have several approaches to do that. You can use solver, you can use abstract interpretation, you can optimization with varying degrees of maturity of the tools. Finally, you can rely on empirical methods. So basically, they are relying on some human expertise there. You need a human to say, I'm going to test some specific examples, some specific data points that are relevant to the testing of my system. And I need my human to justify that. I cannot just do it automatically. And here again, you have several approaches that are well known, like field trials, a posteriori testing, or benchmarking. But like I said, obviously you need to define properly on what grounds you want to validate, and it relates basically to the operational design domain. So if you have a proper operational design domain with clear attributes, with clear distribution of these attributes, what kind of perturbation this attribute can bear regarding the operational domain, you can have meaningful requirements expressed on robustness and stability. So for example, if this is a nominal case on the left, maybe you can have variation like my plane can be red. That's a valid example I can have. I can maybe consider also if my plane can have some adversarial patterns printed on it. Is it something that can happen or not? And obviously, you can have also cases that are non-existent, like this plane I've generated with some generative AI telling that I want a 5-winged plane that obviously doesn't exist, but it can generate one. Right. So when you have this ODE defined, you can then see that maybe formal methods can cover a large portion of the input space, but not remote parts of the input space, because you can enlarge on some parts of of the use case but not very far away. However, statistical is really helpful to go very far and explore on corners on your input space, whereas empirical can cover very, very rare and very specific human-defined cases you absolutely want to cover just to verify that it doesn't kill your system. So you can see that by combining, you might be able to cover a lot of ground of the concept of robustness. So what we've done is giving this matrix of, on the one hand, properties and on the other hand, methods. We try to assess how much they're suitable to assess this. So you can see that, for example, statistical are able to cover a lot of the requirements, but not all. Some of the requirements can be assessed using formal, some of them with empirical, and by combining, you might be able to have an all green checkbox to cover. So for the next steps, we are going to use these metrics in order to express requirements on the use cases and see how much the techniques and tools we identify are able to cover these requirements. And I leave the floor to you.
Thank you for this great presentation. So in a few minutes, I will continue with the Q&A session. But before that, let's see what's next for MLEAP in the future. So in a year from now on, the final report will be published. As you should know, the first report has been released a few weeks ago. The first report and the final report will be available on the EASA MLEAP project page, as well as on the Airbus Protect MLEAP page. So stay tuned for that. So regarding events, we'll have a few more events before up until the end of this project. So we'll have another 2 more stakeholders day, one in January and one in May. And we will also have 1 awareness session and 1 knowledge sharing conference as well before the end of this project. So same as the information will be available on the MLEAP project page, on the Airbus Protect and on the EASA website pages, and we'll obviously we'll communicate about it to promote those upcoming events. Just a more related to communication, so you can do not forget to follow us, and if you'd like to stay informed on what are the latest information about the MLEAP project. So we put down our website and as well as the MLEAP project page on the EASA and on the Airbus project website. So that's it for now. Once again, thank you all for sticking with us and for joining this online and a face-to-face conference. Now we're going to continue with the Q&A sessions. So I think the QR code, we had a slight problem with the QR code, but just refer to the hashtag and the passcode in order to access the Slido, and from them we'll be able to answer the questions. So let's wait a few seconds, and then we'll gather questions and carry on with questions. But for those who are here with us in the room, is there already questions that you would like to ask? Any questions, Xavier, on the Slido?
Not so far. We had a question earlier asking if the slides will be made available. It will be the case. It will be the case. We will post all videos on the Airbus Protect website, and as usual, we will also publish all data on both EASA page and the Airbus Protect page. We had also on the Slido an open poll asking what people would be interested in discussing today. It seems the main topic people are interested is highlight the first experiments. So I know, but we are a bit detailed the result of the first experiment. I don't know if we can elaborate a bit further on the first experiment. I understand you had in the first EASA AI Day some dedicated slides on the first experiment, the first use case. Can you a bit elaborate on how the phase 3 is going and what are the first results?
So yeah, phase 3 was initiated. We had some results on the PCA. I don't have the slides with me. I'm not sure I have the slides with me. Our experiments on PCA were performed on AK6U. So we highlighted some regularities in AK6U that surprised us, back to the expectation that we had on the dataset. So we will be exploring further this the dataset. Also, Shannon's entropy was performed on images, and it was quite promising because we can study the distribution of the entropy like pixel-wise and across classes. So that's a pretty good, I would say, synthetic indicator for datasets like images. I'm not sure it would be as informative for text or audio, but for things like images, it's pretty interesting. So that also means that it's interesting for high-dimensional data. So that's also an interesting point. Can I go back on the slide just to get the listing of the graph? Yeah, as I said, the graph method was a good complement to PCA. We tested it on a very small data set called the Titanic data set, but we think we can scale it quite easily with air quotes on easily on the AK6U data set. And that's pretty nice because this tool is very graphic. It really helps visualize things, and it's a good complement to PCA because it's really adapted for low-dimensional data, while PCA is better for high-dimensional data since it's a dimensional reduction technique. And finally, sample similarity. Here I mentioned a degree of correspondence, which is the metric that we found in our state-of-the-art, and we tested it. This specific metric was really not very convincing, but sample similarity is really is way larger than degree of correspondence, and we will be deepening our exploration of these approaches. On sample similarity, we worked on the STC/STT use case, so audio data. So the idea is that we had to use embeddings as proxy for the audio signal, because working on the audio signal was not very interesting. And so once you have the embeddings, it's basically you are in the vector space, and you can use similarity metrics to compare these vectors. So that's very, we believe it has a lot of potential. We just had a few mishaps with this specific metric, but we will continue to explore it. Is there another question?
Yeah, so we're going to complete and continue with the Q&A with some more clarification. Yeah, I will go to that. So can you just elaborate more about the priorities for the next phase of the project? So if maybe you can go on with that.
Yeah, exactly. Well, just to continue with the experimentation which is in progress. So currently we are testing the different bounds which have been identified. We have started with open source simple use case, high dimensional, and where we can also play with the deepness of the network. we have applied also the boons to the different use case we have. We start to try to understand that depending of where we are in the W shape, maybe at the initial phase where I can choose the architecture, is it a convolutional neural network, a fully connected network, and so on. How can I use these boons to tell me something concerning I am going in the right direction to provide assurance level. I will not call guarantees, but let's say more assurance level that what I'm doing will generalize properly. The first result we have also concerning speech-to-text has been presented by Tiziri, and concerning the images, let's say, here also, what we have seen is that up to now, the boons we have identified are very too large to enable us to take any conclusion concerning how to use these statistical tools in providing assurance level. Nevertheless, not the end, because behind that we have some use case where we have limited number of data and so on. So we need to see how those boons, or maybe new one that we can identify in the literature, can help us, let's say, to frame a bit the generalization purpose in the frame of certification.
Can we also have more information about the priorities on task 3? Arnaud, if you can detail that a little bit. Thank you.
All right, regarding task 3, the 3 use case presents very different challenges regarding especially formal methods. So some of the use cases, for example, ACAS2, can be fairly easily processed using formal methods, statistical methods. So we think we can achieve good results rather easily. On the other side, for example, speech-to-text is something rather new for this kind of methodology, and so we anticipate discovery, good and bad, for that, and we're already working on processing that. Even the evaluation of speech-to-text regarding performance presents some unique challenge. It's not like image detection algorithm where you can have a clear metric of what is performance. So all of that is posing new challenges we want to address and to put in perspective with the requirements that we express to see, can the requirements match these kind of challenges, and can these challenges be tackled? So this is roughly the angle we have regarding the processing of the 3 use case, which is the main point now for task 3. So we're finished with the theoretical work. Now we want to do the operational one.
Thank you. So we have one question. So do you use any entropy maximization algorithm to evaluate image data? One of you can answer that.
I think this is a reaction to what I was talking about before. No, we did not use like entropy maximization to evaluate data sets. It's more the question of can entropy be used to gain insight on the notions of either completeness or representativeness. So it's we are more in an observational dynamic. So I don't think we would be using algorithms like Maxent models for our work.
And then we have a question on the Slido. Is the end goal of this project a EU-wide certification for AI model, with clarification that not everyone is interested in developing them, but verifying third parties' model is needed? And I guess the question is more for EASA. Yeah, if you want to take it, Guillaume, then I can complement.
Yes, with pleasure. No, it's a great question. So first to clarify, the goal of the research project is not simply to certify models. That's really to find out means of compliance for this framework of certification we are putting together, let's say, from the EASA side in the concept paper today, tomorrow in rulemaking, so in regulations and AMCs. And even tomorrow, let's say, we will not certify models, we will still, I would say, certify products as we do today. So aircraft products, an engine, for instance, but not a model per se. Yet the question is very important. This is one of the, I would say, the missing angle in the concept paper at this stage as we talk. One of the points we discussed also in the working group. We have to think about reuse of models, let's say previously developed models or even COTS, machine learning models. That's a very different nature of COTS, I would say, than the ones we are dealing with today. So definitely there is some layer of guidance to put on that. That's very important because indeed not everyone will be developing models, but sometimes in fact using them. Another usage of thinking we have and things we need to include in the guidance is about transfer learning. So really reusing a portion of a model, even if you developed it yourself, without fully retraining it, but taking maybe some, I don't know, layers of a neural network, plugging them into another type of application for whatever reason, change of environment, change of application, or even usage, I don't know, of a natural language processing model in a different context. These are all things we have nothing about guidance about it today. So it's not a scope of the MLEAP project, but as I always say, let's see how many, let's say, research projects on top of that we may need to complement this framework. Definitely on the other side, we will work on that in the issue 2 of the concept paper to have at least an embryo of guidance starting the discussion, and we will discuss with the working group. I take the chance of having Mark Roboff, the chairman of the SAE G34 in the room to mention also, this is one of the discussions we need to have in the plenary next week, how much, let's say, we can take at this stage of the MLEAP into the standard, not to, let's say, unbalance the fact that we will inject something on the other side. That's really important to keep up with the
I bet you can guess the one call.
Please, if you want to come to the floor or take the mic. No, just for the audience, yeah, sure. It's good that you use the mic.
Hi, everyone. Great work. Subgroup 1 is good. So glad this got done somewhere else. My only comment is that if we look at certification framework today at a product level, not at how we're going to do means compliance for AI, but at a product level, right? I would argue strongly, and this is an argument that we've made before, and it's directed our roadmap and our work in the committee. Your use case 2 does not require certification. We don't think it would. Today, it would not, right? So use case 2, which is using a drone to take pictures of a fuselage and automatically classify lightning strikes and other impairments based on the visual characteristics. First and foremost, there are airlines using tools to do that already. Those tools implement AI already. And the critical distinction, right, if we look at most cert authorities across the world, is that it's a maintenance use. And in the world of maintenance use cases, right, you're not certifying product, you're certifying technicians. And in that world, an AI image classifier would be seen by an airline or by an MRO or whomever is doing that type of work simply as a decision support tool. But the regulatory touch point and of course the liability that gets carried by that, nothing to do with what the product can or cannot do or how the product works. It's the A&P that is signing off on the airworthiness document or on the task work that has to be done. So the question I would have for that, because this is a big question that the industry is asking, and I know that Airbus hasn't really been given straight guidance on this, are those use cases something that EASA is going to look to certify in the future?
No, that's a good question, Mark, and I was expecting it from you for sure. Yeah, no, clearly, but I would put it at two levels. The first level is for the MLEAP project. We're looking for use cases that are dimensioning, I would say. So this one brings computer vision, whereas we have also natural language processing. So irrespectively of it, if it will be certified or not, let's say, or approved in the future, at least it's a good use case for the testing. That's the first layer. The second layer is a difficult case to answer at this stage, but definitely in the rulemaking concept we have in the roadmap 2.0, we have this, let's say, preparation of a rulemaking plan in two steps. The first step is let's genericize what we have as a framework first for, let's say, approving or providing the right level of guidance for in view of approving or certifying AI applications. That will be the generic piece. From this generic piece, we have a step 2 that will be the domain-specific touch. So if we think initial airworthiness, there is not much difficulty to make a plugin. Then if we think ATM, it's similar context, but there is a lot going on with the conformity assessment, etc. We need to see how we plug it in or adapt it to it. If we think maintenance, definitely we are in a totally different world, exactly as you said. So we need to be very careful. Now, considering the roadmap levels, we think level 1, most probably you're 100% right. It's already deployed or deployable. That might not require a specific approval on top of what we do today. And we could rely, I would say, on tool qualification, calibration and qualification methods, principles. If we think now level 2, I'm just going one step beyond, where the tool would be a lot more at ease to take automatic decisions, even if there is still a human end user, that might require a bit more than what we do today. If we think level 3, which we have not entered yet, so I don't have the crystal ball completely today, it might be totally different type of operation. Therefore, not trying to revolution, let's say, the world of maintenance, we need to see how we create this layer of assurance, let's say, on the tool, if we request from him to do something that actually a human is doing today. And this is part of the game, but how, let's say, the how-to is still the point we need to work on.
Thank you. That's a great answer. Because you could argue that there are actually good business reasons why you would want to certify these types of tools in maintenance contexts, but doing so would represent a sea change as to how this industry works. Absolutely. And there are lots of things to think about and consider. We'll talk about this next week.
A lot of them, yes. And the organization part is a huge point behind what you say. I fully agree. Yeah.
Okay, thank you.
Yeah, you're welcome.
Oh, if I may. Just to complement, maybe to give a little more perspective on the broader term. If you look at, for example, the healthcare sector, they have exactly the same problem because they say, yeah, it's just helping the practitioner, it's not replacing him. He has to sign off on every decision. But there is a tendency to rely more and more on this kind of automated system. If it's like 99% correct all the time, at some point you might fall asleep and just say yes, and not look at properly at the data you're signing off on. And so there are provision. I need to maybe check that a little bit more. But for example, in the AI Act, there are provision for that. Say that even if it's just a helping tool that you can rely on, you need to take into account the fact that the operator, which is certified, might just not really look at and just say yes all the time. And so you need to bake into the system a mechanism to challenge him, to keep him awake, and attentive to what he is actually signing on.
So I'd argue that this is a worthy discussion. It is not a standards discussion; it's a policy-making discussion. And yeah, so I would argue that where I stand on this personally is that it would make a lot of sense to have some sort of concept around development assurance and certification for AI in an operational maintenance MRO construct. For that to happen, the first thing that, and especially in Europe, because this is actually like the one thing in the world that arguably the FAA is a bit ahead on the curve on, but one thing that we have to look at, even before we get to here, is how much in terms of asset management and MRO operations at a airline level, that has to change. And it has to change dramatically. And there is arguably a holdup in terms of there not being any regulatory pressure or rulemaking on the digitization of operations and the digitization of records. Because without that, right, and this is just one use case in MRO, but so much of what we do, and MRO is also very important to AI and aviation because it's where everyone's cutting their teeth. It's where everyone's doing stuff. It's where everyone's testing stuff and learning, right? So everything we do, for instance, in G34, which is very much focused on design and engineering, creating the DO-178C for AI, right? We all came out of doing this first in prognostics and doing this first in craft health management. Problem is that we don't work in a big data environment. If there were a joint concerted industry effort, regulator backed, to get airlines digitized, then it would be much easier to sit down and have these necessary conversations about what certification looks like in the MRO space, but also we'd be in an environment where airlines and their supply chain would be able to get value out of doing all this. Right now, it's science experiment. But if we digitize at scale, then we get to a point where everyone can start realizing value, and then this will go much.
Each vertical will move on at their own pace, definitely.
Thank you. And Mark, I think you created an even bigger picture, but all of that will be taken into account. I was mentioning.
Yeah.
Okay, so I think that's it for today. Yeah. So I think we're gonna end the online conference, but for those of you who are there will be refreshments and a little bit of food that waits for you. So if you wanna keep exchanging with the consortium member, you can do so, and there is food and the beverages just right outside of this room. So let's end the conference here. Thank you all so much for the online participants. Thank you for sticking with us until the end, and see you next time for the next adventure regarding the MLEAP project. Thank you, and bye-bye.